here to help you think through some of the more GMAT assessment items. So how many people have taken that? Right. And then the rest of you are new, you're taking it for the first time. Tomorrow, excellent. So you're ready to think about this. So what I'm going to do, I'm going to talk to this. They're going to videotape different things of what I'm sharing here too, but I'm trying not to walk away from that a whole lot. But I'll give you just some background on this, on the assessment itself. I know some people have already taken it, and they can probably talk about that a little bit too. But we'll also look at some sample items, and we'll discuss a couple different strategies and ideas that you can think about that hopefully will help you just thinking about this assessment. So, we have lots of people that can help me here today too. That's really good. Some people will correct me when I make mistakes with this. But there are 40 items on the mathematics assessment. You have 1 hour to complete it. So if you perform some calculations around that, you have to move pretty quickly through different items. So if you find yourself being stuck on an item, obviously, but it is computer-based, right? So I mean, you can skip that item and then come back to that item. There are ways to do that within the format. So that's what you have to think about. You don't want to spend 10 minutes on one particular item. It's just not worth your time. And they have to get 16 items right?
I think about half. So
yeah.
I think out of 40, you have to get 20 right.
Yeah, so about 20. Okay, so about 20 items right on it is where the bar is currently set. And about half of the assessment involves situations that involve numbers and algebra, primarily algebra. There are a few that involve calculations, the percents and things like that, and I'll talk about that a little bit here in a second. About a fourth of it's measurement and geometry, and about a fourth of it's probably statistics. Now, these things are probably what I would describe typically as items that you would see like on an ACT or things that you saw in high school. You won't see things that are calculus-based or things like that are on this assessment. But there are a number of things that arise that have the opportunity to trip you up a little bit. So these are things that you definitely need to think through. So we'll look at some of the sample items. Let me just overview all the different sections here first. So the first section, here's a little bit more I was going to tell you in the background too. So there's at the very bottom of the screen, and people that have taken this can talk about this, and at the very bottom of the screen there's this little menu that's down here, and I had to make a very bad image of this. But essentially it says reference materials, calculator, help, and it gives you, this is the practice one, gives you this kind of score report. It keeps track of which ones you've taken. So in the reference materials, it has various different formulas for volume and area. Like, for example, volume of a cylinder would be there. So if you click on that, that's there. So you don't need to spend time saying, oh, I've got to remember how you find the surface area of a cylinder or volume of a cylinder or things like that. You won't need to do that. And there's a little 4-function calculator that you can use. So if you click on that button, it will just pull up a little calculator and perform different calculations there. So those things are there for you to use. So all those formulas are there that you can use. One, again, help me out. Thanks.
Yes,
I appreciate you saving me walking back and forth. So in numbers and algebra, there's a part where, the first part, they have some things with just calculations. So they ask you different questions with, for example, percents. And they'll ask you some different situations where you have to deal with ratios or proportions. On the sample assessment, there's an item that has to do with scientific notation. I can show you one like that. So there are some computations that you do. So you have to perform some different computations like costs. That's what I see in the sample items that are there. Then you get down to some of the things around algebra. There's somewhere you're dealing with different algebraic expressions to see whether they're equivalent. You know, the different things that you did probably in like a first year algebra or second year algebra, there are different things with exponents. There are different things where you're able to find polynomials, things like that right there. There are a couple of questions where they ask you about different properties. So, for example, is this an example of a commutative property, an associative property, a distributive property? And it's not as clean cut as what you may have seen in textbook, and I have an example of one similar to what they gave in the practice assessment. And then they have you solve different kinds of equations. So if you had an equation of the form like y equals mx plus b, you may have to solve that equation for x or something like that. So they're solving this kind of literal equation. So that's what I see on the practice assessment. I don't know if people that have taken it would say, yeah, and there were other things that were on here that are outside of this realm. You should remember things like that. But that's what I see on the practice assessment. All right. So geometry and measurement, they have different ones where you're finding area, surface area, perimeter, volume of shapes. Sometimes there were diagrams where they were missing a chunk, and I can show you an example of one like that on, I can sketch one like that, look at that section, but maybe something like, you know, you have this kind of a square that's here, and there's a piece that's cut out of it. You know, what's the area of the shaded region around here if this is 6 centimeters or something like that? You know, it asks you what's the area of that shaded region. So they're not just, oh, here's the formula for a volume of a cylinder, now calculate with that. It's not, they aren't as easy as that. You have to really think and apply a number of these different ideas. Things like using the ideas around some of the angles in a particular polygon, various different angle relationship, determining different angles, finding different angles that are formed by parallel and perpendicular lines. So those are the different things that you see. Relationships between side lengths and area, surface area, volume. So if you change, you know, if you double the side length in a figure, how would that impact the area? If it was a two-dimensional figure, what would happen? So there are some items that bring out some of those kinds of ideas. Different ones where you apply Pythagorean theorem and you use various different geometric properties. There are some that, I thought I put this on the slide, maybe this is another version of this. But there's some where they deal with, even they'll have a proof that's sketched out and they'll say, okay, so here it goes from this step to this step, what's the justification for that? So there are items that are like that. So again, kind of knowing some of these different properties exist. Okay, let's go to the next one here.
The next one?
Oh, that one? Yeah, that is the next one. Probability statistics. So there are some different questions around probability and using different counting techniques. We were just debating this one situation back there, which was kind of complex, which I don't know if I'm going to go through that one because now we're spending 20 minutes on one item that may or may not occur on the assessment. But there are different ones where they ask you, some are very straightforward about the probability. 10% of the blocks are green, 20% are yellow, 70% are blue. You know, what percent of the overall blocks are blue or something like that. So some of them are not, you know, they're pretty straightforward. Other ones are much more complex using different counting techniques. There are ones where they ask you to, some things about the mean and the median. The one item that was on the practice assessment gave was something around, you know, which one's greater, the mean or the median, given this data dispersion that's there. So they showed a histogram, for example, and say, which one's greater, the mean or the median in this situation? So thinking through something like that, and they have a variety of ones where they're looking at different graphical representations of data. So you may have to look and say, is this a negative correlation or a positive correlation? A couple items were around the idea about how you obtain a sample, you know, like a good random sample, so it's not a biased sample. And other ones where you're reading data from various different data displays, trying to think about whether this is a good data display for the situation. So this is probably the one that the one section with this 25% minus is probably the least familiar, I think, for most people. So most people probably went through a lot, like an algebra, geometry, advanced algebra, maybe calculus kind of sequence, and you may not have taken something around statistics, or maybe there's just a little bit around probability. So in some ways, this may be a more difficult section for some people. Questions about anything that's up there? Thoughts about that?
You might not know this. I don't know the term, but like I know for tests I've taken in the past, people have told me, you know, like just for like a really easy example, if you can tell it's a clear-cut 45-degree angle and it asks you and you don't know how to do it, do they have like is it adjusted to where it can't, or you know, it probably won't be equal even if it looks exactly like
You're
it?
talking about whether it's kind of distorted
Just
diagram
like
or
if you
something
can,
like that?
like if you had a protractor and you can tell that, you know, it was 65 degrees, but you don't know how to find it exactly.
Yeah.
Do you know if it would be exactly what it looks like?
Yeah, I mean, I would mention most of the diagrams are probably not necessarily to scale. I mean, you'd have to use some kind of a geometric idea there. I mean, you may be able to estimate, make a guess, but most of the assessment, or almost the entire assessment, is multiple choice. So there are definitely some examples that you can eliminate based on the multiple choice there. I'll kind of walk you through some examples like that that will help you think about it. Okay? All right, so we're going to look at a couple different items. I'm trying to use some items as examples of bigger ideas that I think will help you in thinking about what's on the assessment. So let's take the section with numbers and algebra. So again, I went through all those different parts, right, that are there. Right, I already talked about those different parts. So let's look at a particular item. Here's one that's just around with computation. So jump to the next one there, please, Mike. Okay, so here's one that they had. I created one pretty similar to what's on the sample assessment. So the distance from Earth to Mars averages 225 million kilometers. We get an interesting scientific discussion about this, but we won't. The distance from Mars to Jupiter is 6.91 times 10 to the 8th kilometers. How far is it from Earth to Jupiter? And again, it's set up in this kind of a format where you have these multiple choices there. Now, just based on even looking at this right here, I would guess you could probably figure out the answer without even doing any computation. Maybe you can just look at that and say, I think the answer would be this, without even doing a calculation. Because you have these different things. This is in scientific notation, but that thing's not right there. Without doing a computation, could you figure out which one it is? A, B, C, or D? Are there some that aren't reasonable? You're not going to talk.
Is A not reasonable?
Why? Why would you say that?
Because it's less than 6191.
Yeah. I mean, you're going from Earth to Mars and then Mars out to Jupiter, right? How can it be less than 6.91 times 10 to the 8th, right? These right away, you could just throw these out, right? I mean, those don't even make sense. Now, if you think about this number here, 225 million kilometers, that's quite a bit less than this right here. If you combine that with this, it's still going to be something times 10 to the 8th. I mean, if you're just thinking this through, C actually is the only reasonable answer here for this situation. And some are like this where you can think your way through it, but you can perform some calculations with it too and think about what that would be. But this is the kind of item that they had on the assessment where this is pretty straightforward, I think. You're performing some computation. As long as you understand what it is with scientific notation, you'll be okay. I mean, it'd probably be helpful to change this one to scientific notation, I would guess, to add those together. Probably would be helpful. You know what that is in scientific notation? 225 million. If I wrote it out, I may have actually put a wrong answer there. I don't know. I have to think about it. Now I think, okay, this is 225 million, isn't it? So I think 225 million? I think so. So what is that number? Then could you add that with this number right here? All right, now you get 1/6 times 10 to the 8th. Now you wouldn't add the exponents there, right? That'd be a bad thing. No reason to do that. That would make a much, much larger. Okay, so I'm just giving you a sample. Why don't you go on the next one here? Blah, 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 blah. So we're not necessarily going to do this one, I don't think, but here's an example of one that they had. I modified this slightly just so we could look at a sample one. But at Alpha University, in-state tuition is $8,000 per year, and out-of-state tuition is $12,000 per year. If the cost of tuition for in-state students increases by 10% next year, what would the out-of-state tuition have to be charged in order to maintain the same percentage difference between the in-state and out-of-state tuition costs? So you're going to have to deal with some percentage issues here. Again, this isn't really an issue around algebra, but it's thinking about the relationship between those. I'll let you think about that item. I'm not sure I'm going to go through that entire item and do that item, but you can think about an item like that. And how would you perform, what calculations would you need to perform? There's actually many different ways to do that, the situations here. At least a couple different ones I can think of off the top of my head that you could use to solve that. Can I go past this one? Is that okay? That'll be a fun one just for you to think about on your own here. I'm going to give a couple like that, but I'm going to try and use some other ones for
Can you tell us
example.
what the answer would be though?
What?
Can you tell us what the answer would be?
Go back to that one. I'm pretty sure it's 13,200. Yeah. Okay, why don't you jump to the next one? So here's an example of an important one that you need to think about this idea with using here. You can spend a lot of time doing certain things, or you can actually look at some of the choices that are here and use some strategies that will save you a lot of time. Because remember, you have to do 40 items in 60 minutes. And I know we were talking to some people about this before, that if you're taking this for the first time, you have all 5 sections to do. And my understanding is that there's no break between any of these sections. You have to choose, if you need to use the restroom, which I assume most people will within a period of 5 hours, you're going to have to choose a section where you're going to get done early enough that you can go to the restroom at that time. So you can be strategic with your use of the restroom, which sounds kind of weird, but you really have to think about things like that. If this section is going to take you longer, you anticipate this section taking you longer, you're not going to want to walk out and spend 5 minutes in the restroom, right, and lose that 5 minutes worth of time. So just something for you to think about. Again, you want to think about strategies that are going to help you get through some of these quickly. So take this example here where we're multiplying this binomial times this trinomial. So you have all these different responses that are here, right, that are different that you could choose from. Now, if you notice this, there's an important difference between A, B, C, and D that you could spend, you could spend probably a few minutes multiplying this thing all the way out. But if you just look at the responses that are here, you're not going to have to spend all your time doing that. What do you notice about all these that are here that can help you think through what little part I can look at? So let's just think about this. What do you notice?
Just need to multiply the first numbers,
Like the
4x
4x,
cubed
4x to
and
the third
5x.
times 5x?
Yeah.
So if I did that, notice that I look at these that are here. Do I see any that are the same or different? Yeah, so true or the same, true or different. So if I did do that, which it turns out to be 20x to 6, I would narrow it down to these two, which that helps me a little bit. But there's one that I think even helps you even more.
Do the last 2 times.
Yeah, so if you look at the x terms here, they're all different, aren't they? If I just knew what's going to happen when I multiply this negative 3x times that negative 7, because that's the only one that's going to give me an x term that's like that. What happens when I multiply negative 3x times that negative 7 there? What am I going to get? Positive 21x. Woohoo! I'm done. It's D. I didn't have to spend 5 minutes multiplying that thing out. So see, thinking about something like that may help you when you're doing it. Just looking at the different responses that are here. Again, you can multiply it all the way out. You can have all kinds of fun doing that, if that's what you like to do. Multiply binomials times trinomials, that's fun. But looking at the different responses there and thinking that through may save you all that time. Okay? All right, why don't you go to the next one that's here. So this is another one that thinking it through and thinking about, what can I do in a situation like this? So this is kind of a messy one. I mean, if I saw something like this, I'd immediately be thinking, wow, I never want to be dealing with those situations. Square root of something and trying to simplify it. I'm going to say something that I would never recommend in an algebra class as an algebra teacher, but this is a strategy that can help you get through some of these items. And all these math ed people that are in this room with me, you can shudder when I say the statement too, because I shudder when I say the statement. But what's something that may help me recognize this? Because really, when I think about this, this means that this expression here is equivalent, means that for any value of x that I put in here, right, it's going to generate the same value for an expression over here, right? It doesn't make any difference what number I put in, right? That's what that means. So a strategy I could use would be to put a number in here for x and just perform a calculation with it. Now, I would choose very carefully what number I put in here, though. You're shuddering, aren't you? Aren't you shuddering when I say that statement?
As long as they stay away from 0.
Yeah, I'd stay away from 0. I'd actually stay away from another number here, too. I'd probably stay away from 1. There's a really nice number. If I were to put in here, what would be a really nice number that would give me nice values here? 4. Okay. That's what I would have chosen, too. 4. I like 4. Why do you like 4 so much? It's not just your favorite number. Why would you choose 4? Now, square root of 4 is 2, and if I take the square root of 1/4, that's times itself is a 4. What times itself is a 4th? I don't think so. A half times a half is a 4, right? So this is really the same as if I put 4 in here, if I wrote that out, if I took the square root of 4 right there, plus the square root of 1/4, this would be 2 plus a half, right? Ooh, 2 1/2. So now the question would be, if I put 4 in for all the rest of these that are here, which one gives me 2 1/2, right? Or something that's equivalent to 2 1/2. So I can perform a calculation with this. So, the first one is what? 4 plus 1 times the square root of 4 over 4. So that's 4 plus 1 times 2.
Okay.
Over 4, is that right?
There's some parentheses.
Did I miss something? Oh, it's 4 plus 1, it's here. Sorry, thanks. Good thing you're watching me. So 4 plus 1 is 5 times 2 over 4. Is that right? Not great? 10 fourths. 10 fourths is 2 1/2. So it might be this one. So I take a second and see if I put 4 into these other ones, if it also gives me 2 1/2. And if it doesn't give me 2 1/2 in all those other ones, I know this one's the one that's equivalent to it. I mean, you could spend some time trying to simplify that one. I'll tell you what, that's just not fun. So, something like this may be a strategy to help get you by. Again, I'm saying something that if I were your algebra teacher should probably shudder if I said something like that. But it'll help you get through some of these items much more quickly. But again, you have to choose some numbers that make sense. Okay, why don't you go to the next one here? Okay, here's one that we can all think through. So here's the statement. So the statement, 3 plus 6x times that quantity times 7 equals 7 times the quantity 3 plus 6x. It's an example of which of these properties: distributive property, commutative property, associative property, closure property.
Is it distributed?
Good question. Is it distributive?
So I mean,
It kind of looks like distributive. Why do you say it's distributive?
because you just distribute the 7 to the 3 and then the plus 6x.
Right, and that's what the distributive property means, right? If you're taking 7 times 3x plus 6, I don't even know if that's what this one says, but something like that. You take 7 times 3 and you get 21, right? Plus 42, 21x, right? Plus 42. Right, that's what the distributive property would say, but this one doesn't quite say that. Notice there are these parentheses here, so they're not as straightforward with some of these properties as what some of the ones that you may have seen in class or in school were.
Would be because it's saying like whether you put the 7 in front or behind,
Yeah.
it's gonna be the same.
So you have to look at what's going on here. So it's really saying there's something here times 7 equals that 7 times the same something, right? So it's really just switching the order of them. So it's saying like 5 times 3 is the same as 3 times 5. So is that an example of the commutative property? Yeah, that's an example of commutative property. So the commutative property says that you can multiply in either order for all real numbers. We can get discussion about things that aren't commutative when you multiply them. But for all real numbers, that's perfectly fine. You can multiply them together in either order. So you see why that's commutative property? You see what it's saying? See how this is different from this? And now they're trying to trick you with some of these things by putting like, oh, if you pay attention to parentheses and you think, oh yeah, it's distributive property, but they're not really distributive. They're not really doing something like this here, are they? Associative property, you know what that means?
I remember those.
Yeah, so you're grouping things, in this case it's you multiply, right? So this is a property of multiplication. Distributive property, closure is a little different critter. I don't know if they would give you an item related to closure. You know what closure is? So like if you multiply like a whole number times a whole number, you stay in the whole numbers, you don't jump out of the whole numbers. It's closed under that. Versus where if like you divide a whole number by a whole number, you could jump out of the whole numbers. Take 7 divided by 9, you get 7 9. Ooh, it's not a whole number, right? It's making that. It's a rational number. Yes, sir.
Can you go over the associative property real quick?
Yeah, so an associative property would be something like this. I'll give you an example just with numbers. So 2 times 3 times 4 equals 2 times 3 times 4. something like that. So if I multiply the 2 times the 3 first and then take it times 4, it's the same as taking the 3 times 4 first and multiplying by 2, right? Which is true for all of these real numbers. I should have written it over here, huh?
It's okay.
Does that help some? Right, and addition's associative, multiplication's associative for real numbers. Subtraction, I don't know what to think about that. Division, think about those a little bit more. Okay. Okay, so we'll just start into one like this, okay? Because there's another idea that's coming out. So those ones with properties, if you know those properties, those are pretty fast. But if you don't, you can skip those or, try and answer them, guess, and go on. Because it's not, no sense spending a whole lot of time on something like that. So here's an item that I think it'd be good for you to think through just what's a good strategy for you doing this. So the length of a rectangle is 4 times its width. If the perimeter of the rectangle is 400 feet, what's its area? So if you saw an item like that, what would you do? What would be the first thing you would do?
Draw a picture.
Exactly. Good answer. That's exactly what I do. I try to draw a picture of, right, not Townsend Hall, not the columns. I try to draw a picture of what?
A rectangle.
Yeah, so I probably draw a rectangle. I'd say, oh, need something for the width. X, good choice. Yeah, let's put something there, and the length would be what? 4x, right? Then you could deal with this issue right here. Right, you can think it through. The perimeter would have to be 400, right? So I can think, oh, well, this side over here is going to be x, this side over here is going to be 4x. If I add all those up, I get 10x, right? That's the perimeter. So this is kind of a combination of some algebra and some geometry going on here, right? So if I added all those up, I get 10x equals 400. Right, I can say, ooh, x is, I think, 40 there. So this side's 40. This is 160, I think. And now I can figure out what the area is. Right? So not too bad. I think that's 6,400 square feet. How do you feel about an item like that? Questions? You could think your way through that.
How did you get your 4x?
How do I get to 4x? Because it says something special here. It says the length of the rectangle is 4 times its width.
Okay.
Right, so I said, well, if I'm going to call this x, then this has got to be 4 times as much. Now, I could have called it y, but that would be kind of a messy thing to deal with, right? So I know this relationship actually between the length and the width.
Okay.
We'll do one that's kind of like that. I think actually the next one kind of helps you think through some of this too. That's the next one's, nah, that's not the one. There's one after. There's one after. That's okay. Let's look at this one for a second. Blah, 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 blah. Yeah. So here's another one. They're kind of moving back and forth between these items where there's some algebra versus one where you can think about ratios. There are 800 students in the school. The ratio of boys to girls is 1 to 3. If the enrollment of girls increases by 50%, now what proportion is going to occur? Assuming the boys aren't changing, I guess, right? Number of boys in the school. So you're doing some calculations here with this. I didn't actually put an ABCD here. There's one that you could, if you want another one, just to think your way through. There's no need to use algebra here, but just thinking about what percents mean and ratios, and you're using some of those ideas. So I'll let some people jot that one down, and I'll look at the next one.
Can we go
You
through
want to go back to that one? What?
Can we go through one like that with the ratios?
You want to talk about, let's go ahead, let's talk about that one for a second. So how would you do this? That's fine. What would you do? So if you read that first sentence, that tell you anything? 800 students in the school, ratio of girls to boys is 1 to 3.
First figure out how many girls and how many boys there are.
Could I figure out how many girls and how many boys there are then? How many girls are there? One girl for every 3 boys, good. So if you're looking at, so if you're thinking about, here I'll draw my girls with a little we'll dress here at the bottom. Right? I've got one boy for every 3 girls, is that right? Or the other way around? One girl for every 3 boys. So here's my one girl, right? For every 3 boys that we have. So out of 800, how many girls am I getting?
200.
How'd you get that?
Divided into 4.
Yeah. So you're thinking every four
Yeah.
people, right? Something like this. So you're thinking this ratio is going to occur all this time. This in some ways, it's one out of every 4 people is a girl, right? So 1/4 of the total number of students are girls. Right? So 200. So now that's going to help me. I have 200 girls, and that means I have how many boys?
6.
So I'm going to write these things down, what you're saying. So I know that 1/4 of students are girls. I can multiply that out. 1/4 times 800 gives me that. So 200 girls, I have 600 boys. Is that right? Okay. So now what do I know? So the number of girls increases by 50%. Nice number. I think if I do that in my head. So how many girls are there? Now there are going to be 300 girls. How many boys are there? Still 600 boys, right? Okay, so now can I figure out what percentage or what part of the students are girls? Yeah, well, you can think 1-to-2 ratio, or it's 300 out of 900, depending on what is it out of the total students? It says what portion of the students. So I'm assuming they're thinking about all the students here, right? So there are a total of 900 students. So I'm assuming it's 1/3 of the entire. If they're asking what's the ratio of girls to boys now, we could answer it with what you just said. But if they're looking at all the total number of students, then we're going to do this. So you have to think about what is the question asking in something like this too. And I'll guarantee you, they'll have the, if you're not reading through carefully, they'll have the incorrect answer there as one of the options. So it is important to read through what are they asking for. Okay? You do one like that? You do one like that in like a minute, 20 seconds? That's the question, right? But one like this, if there's something where you think, I can get this one right. This other one, I don't know enough. Better to spend a little more time with one that you think you can figure out, too, than spend your time thinking through one that, it's so confusing, and it's going to take me 20 minutes to do this one. Again, that's just the way the assessment is. Just trying to help you think through, this is your taking the assessment. Okay, so here's the next one. Excellent. Okay, here's an exciting one. Woo! This is a really exciting one here. Okay, so here's one. There's an important idea here. And this arose on a few of the different items that I saw there on the assessment, which I think in some ways is an unfortunate thing. But we'll talk our way through this one here. So for 2 children whose ages are consecutive odd integers, whatever the heck that means, right? 4 times the smaller integer is 30 more, not 30 times more, 30 more than 2 times the larger integer. Which of the following equations could be used to find the ages of the children? All right, I'll give you a couple minutes to think about this. See if you could write some kind of a equation here for this. Once you had a chance to think about it, maybe a little bit on your own, you can talk to those people next to you and say hello and let them get good snacks, and then talk about that a little bit, what you're doing for this, because this is an interesting one. See what they write for that one. You can talk to each other. Not sure where to start.
I don't know, consecutive odd numbers, so would that be like 7 and 9?
Yeah, so 7 and 9 are examples. What are other 9 examples? Those are consecutive odd integers. 21 and 23, consecutive odd integers, right? 3 and 5. There are quite a few of them, aren't there? Consecutive odd integers.
X and X plus 2.
Okay, so we'll get them launched with your idea here, right? So the smallest one would be what, did you say?
X.
So you can say the smallest one's x, and the larger would be,
X plus 2.
the other kid's age must be x plus 2. Okay, so one's x plus 2. Now can you write that? Follow that next part there? So the consecutive odd integers, so one's 2 more than the other all the time, right? That's true of consecutive odd integers. True of consecutive even integers too, that's kind of exciting. It's odd numbers, it's always a lot odd numbers. Oh, man. So can you write that thing? This is the hard part right here. Because there's a tricky thing going on here. So it says 4 times the smaller. Somebody help me out with that. What's 4 times the smaller? 4x. Okay, now I kind of just leave this other thing over here for a second. It says this one is 30 more. This one's 30 more, it says, right? Okay, I'm just going to leave that for just a second. I'll come back to that idea here in a second. 30 more than 2 times the larger. What's 2 times the larger? So I write, okay, so I could write 2 times x plus 4, right? This thing, if I want to, right? Twice this smaller one, right? Now the question becomes right here. This is a very difficult thing, and you have to think this through. In fact, we know that a lot of college students have a hard time with this. Even college students that are taking advanced mathematical topics have a hard time writing what goes right here. This one is what? What did I say about this amount right here? It's what? This is more, right? How much more is this one than this one over here? This one is 30 more. This one is 30 more. So if they're going to be equal, what are you going to have to write there? Oh, you're going to have to write, very good, I'll tell you what. That is the part that's going to confuse most people because they're going to want to add 30 to it. But it says this one is 30 more. So if you add 30 more to one that's already 30 more, it's not going to be equal to that other one, is it? Right? It's going to be even that much more. So you have to write minus 30 there. Now, if you look through all those that are there, it's still kind of confusing, isn't it? Do you see one up there that's the same as this one right here? Which one is? Oh, but look at B. Oh, see, here's B.
That's
Ooh,
so cute.
they think you're not gonna write 2 times the quantity, right? I mean, this is really 2x plus 4 over here, right? And this is 4x minus 30, right? So it's not B. Oh man, see that one like this? They're gonna, I bet some people definitely wrote things like D down too, because they wanted to write plus 30 there. It's not D, it's not D. Which one is it? It's A. Well, why is it A? What did they do?
They simplified.
Yeah, they divide everything by 2, didn't they? See, now there are a number of them that are like the one that are here, and then they say, this amount is 30 more than this amount over here. And your temptation is to be to write plus 30. But that's not going to make them equal, right? These things are supposed to be equal to each other, right? This amount has to be equal to that amount over there. Okay? So when I saw the practice assessment, there were probably 3 items that had something like this on there. So you're going to have to think very carefully about what those things mean. I mean, you have to... Go ahead. You're gonna ask.
How did you decide to make the smaller one x and not the larger one x?
We could have. We could have made this one x and made this one x minus 2.
Okay.
It would have worked, right?
Okay.
You know, it's whatever you like. If you like that. We would have had to do some more calculations down here. But it would have been fine. Okay, what's the next one? Do we have another one that's here? Are we done with that? Okay, so here's a really standard kind of one. Well, you see this on a lot of like ACT type assessments and things like that. You got this restaurant charges $7 for a child's buffet, $10 for an adult's buffet. One evening, they take in $2,438, assuming no tips or tax or anything in relation to this. So contrived situation, and 290 customers. So how many adults were served? No? I'll let you jot some notes down, but we'll talk our way just at least through setting up. All right, so how are you going to first approach this? What's the first thing you're going to do? You can guess and check. Probably not a good strategy for this because the numbers are really large. What would be the first thing you do?
Set up an equation.
Okay, and how would you do that? Using variables probably, right? What don't we know?
Amount of customers.
Yeah, number of customers, and there are two different kinds of customers, right? What are the two different kinds? What are they?
Kids and adults.
Yeah, so we have the number of children, right, that came that night. We don't know what that is. We don't know the number of adults, right? We don't know that. But I bet we could write some equations very quickly that talks about this relationship. Let's take this more straightforward. 290 customers, what does that tell you? How does that relate to the children and adults?
Add them, they're equal.
290 total.
Yeah, so if you add them, right, if you add the number of children and the number of adults, you get
290.
90, right? There aren't any dogs or anything like that we're keeping track of, right? It's just children and adults. That's all it is. Now we have to deal with this cost issue. How do we get the, what is it, 2,438? Right? So how do we figure out the cost? If we had X children there, how much does it cost? 7 for each one, right? So 7X. And then how much for each adult? 10, right? And Y. And then you can solve this system of equations. Use substitution, multiply them both by something, right? Use one of your techniques for that. Now you can bet, though, I'll let you do that on your own fun time. You can bet, the question that asks is how many adults were served. Guess what one of these numbers up here would probably be? Probably the number of children, right? It's not asking you the number of children, so that's a wrong answer for this. All right, so you have to be careful again about answering that question. Okay? You can solve a system of equations, right? Spent a lot of time doing that.
How do you know 290 is the wrong answer?
What?
How do they know 290 is the wrong
That
answer?
does look like the wrong answer, doesn't it? Why do you think that's wrong?
Those are the overall.
Yeah, that's probably not right. If you put that, so that's not a good thing. You're not reasoning through the situation very well, right? I don't think that the 290 of them were adults. You could do a little calculation and see. I think it'd be $2,900. There's some other tricks you could do with this too. You can subtract certain things away. We're not going to get in that big discussion, but you can use algebra to solve this too. All right. Is that it for algebra? Not any more there? Woo, geometry measurement. So we'll do a couple, just look at a couple examples like this. So again, all the stuff that I talked about for geometry, right? So go to the next one, Sarah. Yeah. Okay, so they give one like this. You have a cylinder, radius is 4 centimeters, height is h, has a surface area of 128 pi square centimeters. What's the height of the cylinder? There's all these different options. So what would you want to do right away? You're taking the assessment. What would be the first thing you want to make sure that you're dealing with?
Do the equation.
Yeah, so what's the formula, right? What's the equation that we use to find the, we don't want volume, we want surface area, right, of a cylinder. So, you look that up on your little thing down below, and hopefully it'd say something like this. You have two circles in a cylinder, right? Whoops. 2 pi r squared plus 2 pi r squared plus 2 pi rh. That sound right? So here, you look up that one, right? For surface area of a cylinder, because you've got two circles, right? You think about it, here's a cylinder, right? Here's what a cylinder looks like. You've got radius, and what's the radius? 4. We don't know the height, right? So you've got to find the area of these two circles on the bottom and this part that goes around the outside of your cylinder, right? So now it's just a matter of plugging these things in and figuring out what the height is, right? You know what the radius is. It's 4, right? 2 pi times 4 plus 2 pi times 4, 4, and then times the height. And what's the total? 128 pi. So you just do some calculations to that. You can figure that out.
Square. 2 pi 4 squared.
Oh, 4 squared. I missed the squared part. I thought I already squared it. Thanks. I should just, you should have asked everybody, what did I just do wrong? Is what you should have done. Right? And see if they catch it. Okay. So you figure out what the height is and you just solve this for height. Okay? I think you could do that. So, there are items like that. It's just applying. That's probably as straightforward as they get for a geometry and measurement type problem. Why don't you go to the next one that's here? Okay, so there's different ones where they ask you to find angles, and usually they have some kind of variable here. So what is the relationship that you have to know on something like this? Yeah, all the angles, are they all the same amount? What's the sum of all the angles in that figure? That figure has 1, 2, 3, 4, 4 sides. It has 4 sides. So do you know what the sum of the angles is? 360 in any of them, right? So they may give one with you like a triangle. You have to know the sum of the angles in a triangle is 180, right? You just use that idea and you can solve that. So there's some that are like this kind of item. Okay? You probably did a million of those when you were in high school. Oh, this is a really interesting one that they had. I changed this one a little bit. It was on the sample one. So a right triangle has legs of 6 and 8. What is the length of the altitude of the hypotenuse? What is the first thing you would do on this one? Excellent. That's exactly what you should be saying. Draw a picture. You have some kind of right triangle. Right triangle. I won't make any right triangle jokes. Right triangle, and its legs are 6 and 8, right? And we're supposed to find what? What are we supposed to be finding?
Yeah.
Altitude. What's that altitude thing? What's that mean? The altitude of the hypotenuse. This is the hypotenuse, right? So what does that mean, altitude of the hypotenuse?
How far away from the right angle?
Yeah, so if I keep down at a right angle here, that would be the altitude, right? This is how high is it? If this is the base, how high is it right here? So that's what we're supposed to be finding. Now, one thing's probably pretty easy to find here. That altitude is going to be a little bit more exciting. But what's the one thing that I probably can quickly find?
Hypotenuse.
Hypotenuse. How am I going to find that hypotenuse? Pythagorean theorem, or you may recognize that this is a special triangle.
Isn't it 2 times the 6 or 2 times the 8? I know it's one of those.
Yeah, so there's a special triangle, right, called like the 3, 4, 5 triangle. Ooh, 3, 4, 5. You remember that one? 3, 4, 5 is a special triangle. This is twice as much, right? This is a 6, 8, 10. So if you remember that, ooh, I didn't have to do all that exciting Pythagorean theorem stuff. But I could have done that. This is a 6, 8, 10 one. Now it still becomes the issue of how are you going to find that height there?
Treat it like the leg of a triangle.
You think it's the same as this length here?
No, I mean like treat it
Oh,
like some
separate
triangle.
angle.
Do you like, somehow I'm going to try and figure out like this distance, you think?
Yeah.
Yeah, it could be tricky. I wonder how far that is. I don't know how far that is. See, and this is one where you end up with a bit of a dilemma when you get to this point. If you notice one thing, if you remember one thing, this actually could be really quick from this point. But it's I mean, I know how I'm going to do this. Do other math ed people in the room? How are you going to do this? I'm going to deal with the area, is how I'm going to deal with it. Because I can find the area of this is the base times the height, right? Half the base times the height. So then what's the area of this thing? 8 times 6 divided by 2, right? 24. The area of this thing is 24. Well, now if I have this as the base times this is the height, right? It's going to be the same thing, divided by 2, of course. So whatever this thing is, the area of this thing is 24 square units. So I'm going to have to take 10 times something and divide it by 2 and get 24 again. Too hard, huh? So you notice, it's not just a straightforward application of the Pythagorean theorem. It also made me think, is there anything kind of special about this that could help me figure out that height? I'm using the idea that, well, the area doesn't make any difference which base and which height I use, right? Correct, use this as the base and this is the height, and I'll use this as the base and this is the height. They both have to be the same thing. You don't like that problem, do you? I thought it was kind of ingenious, fast. But you know, things like this could be are a little more complex, and this is the kind of item that they have in the sample. Yes?
You said it was 10 times x over 2.
Right, yeah, so if I take 10 times what this thing that I'm missing, the altitude, right, divided by 2, it better give me, what? What's the area of this thing? 24? Is that what you said? Yeah. So I think it's 4.8, isn't it?
I just don't understand why it's divided by 2. Because
Oh, to find the area of a triangle?
well, I understand that part, but
Yeah, well, now I'm over here. So if I turn this triangle on its side, like this, right? I'm over here with this being 6 and this being 8 and this being 10, and I'm trying to figure out what this is, right? So I'm going to take the base times the height and divide it by 2. Right? So that's what I'm doing. 10 times whatever this height is divided by 2 has to give me that 24. You didn't like that one, huh? That was like one of the ones they had in the sample assessment. So, you know, again, some are pretty straightforward. Ones like this, you may get to a point and say, well, I'm going to have to leave this for a little bit and come back to this item. You have scratch paper while you're doing this? Is that what they do? They give you scratch paper?
It's like dry erase board.
Oh, dry erase board. Oh, that makes it more challenging, isn't it? Because it's like, oh, I want to erase this for 2 times, you know, the next 3 problems or whatever. You know, so that's what makes it hard, using the dry erase board. I forgot about the dry erase board. Okay, what's next? Yeah, I mean, here's the sample one you can look at. I don't think this is a big one to go through. You know, they just give you 3 of the points that are on the vertices of this rectangle, and they say, well, what's the area of that rectangle?
Measure that one.
Yeah, you draw it, right? That would make good sense, right? You draw something like this. And sketch where those points in, figure out what the height is and what the base is for your rectangle, and then you can easily figure out what the area is, right? You're going to be able to do something like that. Again, this is a lot easier than the one we just did, right? Because this is just plotting things on the coordinate grid, you know, recognizing how far it is as you go. You could do this, right? Just plot where those points. Of course, it's only giving you 3 points, right? You know, hopefully they're all nice ones. It's not tilted on the graph, you know, and then you can just say, oh, the third point, the other point's got to be over here, but all I really need is this distance and this distance here, don't I? And I'm done. Okay, so probability statistics. I have a couple items here. I don't like either the ones I had give you. I couldn't give you something that had all the different graphs and stuff like that in there. Go back to that stuff that's there for a second. So here, the mean and the median. You know what those things are? What's the mean?
The average.
The average, right? So it's adding them up and dividing by the total number there gives you a sense of those. Now, the mean gets distorted if what's true. So if I look at a data set, sometimes the mean is a lot more than the median.
Because it takes into account like the ones at the very far end.
Right, so you have this big outlier, right? So some things they report, like they'll report median house prices, right? They won't report mean because somebody else out here buying this $50 million house, and it distorts and makes the mean look really large. So they report the median. The median is going to be less than the mean, right, with this kind of outlier that you have. That's an important thing to note. You know, if you were looking at a graph of some data, you know, and you had a graph of some data, you know, let's just say we had some points plotted here with, you know, different amounts that were here. I'm going to do a really bad distribution of something, but let's just say, you know, most of the data is over here, like this, and then you have a couple that are out here, right, that are much larger. Is the mean going to be larger than the median in that case? If these were really large numbers, is the mean going to be larger than the median? Yeah, it is. It's going to be, because you have these big outliers out here that are dragging the mean out here and making that a much larger value. So that's an idea that they're trying to get. They don't ask you, you know, what's the mean in that sample items. They ask you to think about what the mean is, how it's related to the median in the ones that I saw. Do you know what a negative correlation is versus a positive correlation? So a negative correlation would be something where, you know, as this value increases, this one's decreasing. My statistics, but folks, what's a good example of something that is one thing increases, the other one decreases? The cost, right? If you increase the cost of something, what happens to the number of people that buy it? It decreases typically, right? It gets to the point, right? I don't know if it's always this linear, but at least this is what happens. You have this kind of negative correlation, right? Versus some things have a nice positive correlation. What's something that has a nice positive correlation is this increases, this increases. Probably as we get more people in the world, the amount of food consumed is more. I'm just going to go out there and just say that. My guess is that's probably true. Right? Hard to believe that it would go down. There would be any kind of negative correlation. That's what they're talking about, this kind. And you can see this in a graph, right? This has a negative correlation. As this one increases, this one's decreasing. And the opposite's occurring here. They're both increasing. Random samples. Have you talked about that in school? Remember that from, how do you get a good random sample? You go to the student center and you ask everybody that's in to make a random sample. Is that how we do it? No, probably not the best way, right? Because certain people are there eating. It ends up being a biased sample, right? So if you can randomly pick some people, you know, or pick some people like out of a hat or something like that, you get much more likely to get a random sample than this kind of biased sample. If we were trying to get a good sample for all the students here at MU, would we pick College of Education undergraduates to get a good sense of all the undergraduates? No, why not? Yeah, and we actually have a bit of a slant. Did you know this in the College of Education? We have more females than males. We do. So it's a lot more than what it is in the entire campus. Right? Sure. Magic could come. So, you know, it wouldn't be a good sample, would it, to pick something like that? So, you know, it's just thinking about how you can best do it. Okay. So, how much time do we have left? Looking for matching with this clock. Just 2? Okay. Well, this is, I don't know, I don't like either of these examples, but here's one example like what they have here. So you have 5 different shapes within a bag. We're going to pick 2 shapes in this bag. Oh, 5 different shapes in a bag. Oh, it didn't say. You know, I guess it says. What is probably the shapes C and E are going to be chosen? So if there were all these shapes in a bag, A, B, C, D, they're labeled that, what is the probability that I would draw out C and E? How would you do this? So if I'm just going to draw 2 shapes out of that bag, what's the probability that I get C and E? Strategy? So let's just say I did draw 2 shapes out of that bag. What could I get? Can somebody give me an example? What are some shapes I could get?
A and B.
A and B. What else could I get? A and C. A and D. A and E, right? These are all the possibilities. I could get, I wouldn't write B and A though, that's the same thing, right? I would write B and C, B and C, B and D, B and E. What else could I get? C and B, C and E, D and E. So how many different possibilities are there? 10. And what's the probability that the one I choose is C and E? 1 out of 10. So this one's small enough that you could write them out. But they didn't make it so that there were like 50 sheets in that bag. That would be much more complex. We have to have some other counting technique to deal with that issue. So there's an example of the kind of probability. I'm not going to do that last one either with those letters today. So I'm going to stop here for a second. It's 3 o'clock, right? 2 o'clock. 2 o'clock. Thoughts, questions, ponderings? Okay. So make sure you sign that one sheet with the student name and number. You need to do really well, because I think this is the only way I'm going to get paid for doing